Welcome to this video for the University of Greenwich Engineering Department Future Technologies course. In this video I will be connecting the Pixy to a PanTilt mechanism provided by the university. So to get started we will look at how the PanTilt mechanism is assembled and how the connections are made. To do this I made a search on the internet for the standard Pixy PanTilt mechanism to get an idea of similarity. I found the mechanism provided by the university was almost identical, and therefore I could copy the website assembly guide and connections. Finally, the USB cable is plugged in and PixyMon is run on the PC and PanTilt demo initialized. Once assembled, I'm able to show Pixy can be trained to follow an object, in this case a red ball. As you can see, it's identified on the screen behind, and the Pixy module is tracking it using the PanTilt mechanism. So you can see it goes up and down, so Pixy adjusts constantly the image so it's best, and left and right as well. Interestingly, when two objects are placed in front of Pixy, it will take the closest object to zoom in on the most, or focus on the most. So here I'm about to place another ball, so you can see the ball roll past and you'll see Pixy's reaction as the ball is closest passes, and then it will revert back to the previous ball, which is then the closest once the ball's gone past. Now I will control the PanTilt mechanism externally using Arduino UNO connected to the Pixy board. Here is an updated connection diagram showing the connections on the Arduino UNO and the Pixy module. So this is a new configuration. Here is the Pixy, here is the Arduino UNO, here is the external power supply, and here is the data from the serial monitor. So as an object is placed in front of Pixy, it reports back via the UNO the position. The UNO then adjusts the position of Pixy on the PanTilt mechanism, and then continues to track the object. So as you can see now, the data is coming back and being tracked. When multiple objects are placed, Pixy will then report multiple objects as shown on the screen now. Next, I decided to use the Arduino UNO to drive the servos directly and control them in a sweeping motion. So the setup has now been changed. As you can see, the servos are now connected to pins 2 and 3 on the Arduino UNO. So the program will make the servos sweep left and right, up and down. It also reports back any detected objects as well. Pixy will not track them because the servo is independently controlled by the sweep that's been written. So currently I'm holding the ball as the servos turn Pixy. This proves that you can have independent control of the servos should the user need to. In an ideal world you could use buttons to adjust up, down, left, right, etc. As soon as an object is removed from Pixy, it no longer reports to detection. So now we can see Pixy starting to move downwards. And as it's now detecting the objects again, because they're in view, it is now reporting their positions. Finally, I speed up the video a little bit so you can see how the servos control Pixy's movement. However, if they left them on real-time speed, it takes quite a while because it has to update the objects detected each and every time. In all the clips I use an external power supply. This is because if I didn't, I found the servo acted erratically from the USB power. Thank you for watching my video. I'd like to make an acknowledgement to the University of Greenwich for providing the PanTilt mechanism as well as the Pixy.